Double pipe heat exchanger. H1. Apparatus description. Objectives. To determine the heat transfer rate between a flow of hot water and a flow of cold water as they pass through the 2, 4, or 6 pass double pipe heat exchanger in a parallel and or counterflow manner. At least 3 different arrangements from the above possibilities should be tested. The overall heat transfer coefficients and the heat exchanger effectiveness should be determined from the experimental data for the double pipe heat exchanger configurations chosen and compared to what you would expect theoretically. Preliminary measurements. Take the preliminary atmospheric pressure and the room temperature from the weather station in the lab. Measure the pipe length where the hot and cold water flows interacts using the ruler. Also measure the distance between the thermocouples. Setting the apparatus for run number 1. Make sure that the large water supply container with the immersion pumps is filled and connected on the hot and cold water inlets. Open and close the appropriate hot and cold water valves to match the first exchanger configuration, for example, 6 passes counterflow. Switch the boiler heater on and set the transformer to give a maximum current of 6.5 amperes. Do not change the setting of the transformer. Switch the digital Omega meter and turn on the hot and cold water immersed pumps. Make sure the rotometer valves of the hot and cold water flow are fully opened in order to let all the air bubbles out of the heat exchanger. Sometimes the pumps may have to be shaken in order to release the collected air in their inlets. When no more air bubbles are detected in the pipes, the rotometer valves are adjusted to the given flow rates. Wait about 15 minutes for the system to reach steady state condition. That can be confirmed using periodic checking on 1 or 2 temperature readings. When steady conditions have been achieved, at least 2 sets of temperature readings measured by the thermocouples should be taken at appropriate locations for the chosen configuration. By moving the switch to a certain number, the required temperature by the corresponding thermocouple will appear on the digital display. Write down the voltmeter and ammeter readings. Measure the flow rate using a calibrated counter and a stopwatch. Collect 500 milliliters, or 1 liter of the cold water, and calculate the average cold water flow rate. Repeat the same process to find the average hot water flow rate. Don't forget to write down the rotometer's readings and compare them to the averaged flow rate values. Setting the apparatus for the following runs. Two main variables can be used to set the following runs. The first variable is to set a certain configuration of the parallel and/or counterflow in the heat exchanger passes, and the second variable is the hot and cold water flow rate. Set the hot and cold water flow rate. Wait 15 minutes to allow the system to reach the steady state condition. After that, collect at least 2 sets of temperature readings measured by the thermocouples. Also calculate the average flow rate of the hot and the cold water respectively, and compare these values with ones taken from the rotometers. Set the apparatus for the following run. Set a certain configuration of the parallel and/or counterflow in the heat exchanger passes. Shutting down the apparatus. To shut down the heat exchanger apparatus, follow these steps. Turn off the hot and cold water immerse pumps, turn the digital display off, and turn the boiler off.